Hello friends, and from today onwards we are going to create the C# application for our trainer. So in this video we are going to discuss the major process functions, or rather major memory functions, and regarding to this trainer. All right, so the most important function that we are going to use in this trainer is kernel 32's write process memory functions. So let's have a look how that function and how are we going to import it to our C# application. So as you can see, I am already installing the C# here. So in this time it's best to discuss these functions. All right, so as I described earlier, the write process memory function and the read process memory function are the most important functions. So those are the key, those are the two key functions that play a major role in this C# trainer program. So this write process memory function allows us to write to the processor's memory. So let's have a look at that function. So in this case, I'm just going to type write process memory. All right, and I believe it's in kernel 32. Okay, so this is the write process memory function. So it's actually in memory api.h. Let's see the actual DLL file. All right, here's the function. So it's basically said writes data to an area of memory in a specified process. The entire area will be written, must be accessible, or the operation fails. All right, so this is the function header. And okay, if we go through one by one, so it's a boolean, so it should return a true if the function succeed, otherwise it returns a false. If the function is false, we have to get the error, the reason of why it is failed, to get last memory. All right, okay, so this is write process memory. First parameter, it requires the handle to the process that we are going to write to. For example, if we are going to use this trainer program, no, sorry, not this one. So this is the one. So if we assume that we are going to write to this processor's memory, so we need the handle from this program. So that's the first parameter, and the second parameter is the base address. So this is a void, pointer void base address. I believe it's a long pointer void base address. So that is the address that we are going to write to. Not the address is the offset base address plus the offset that we are going to use. I will discuss that in later, what that I meant by the base address plus the actual address. So let's discuss when we go through. Oops. All right, so next one is the buffer. Okay, the data that we are going to write to, it is a buffer of bytes. So if you are going to be in C++, this will be pointer to character or character buffer, and the size is the size of the buffer, and the number of bytes written is the one that returns how many bytes written to the processor. For example, if the buffer size is 10 and you specify the number of size of the buffer is also 10, and you pass this execute this write process memory, and so you will have a int variable, size t variable, and you insert it with ampersand, and you get the number of bytes written back after this execution, so you should get 10. All right, why we specify this end size? So can't we take from that? The answer is you cannot, because this is a pointer to buffer. So this buffer can be dynamically allocated or statistically allocated, right? Compile time allocated. Okay, so if this is compile time allocated, then we can use size of, but size of is not going to help you, because assume that your buffer size is 64 bytes, all right, and the addresses that, so let's say we are writing a int32 variable, so that means integer, 32-bit integer, so byte size is 4, but in your buffer you have 64 bytes and you are going to write 4 bytes to this process, all right. So if you pass if you don't assume that you don't have this variable, the internal write process memory function has to calculate through this size of variable, all right. If the size of variable is allocated in the compile time, say that your buffer is 64 bytes, the size of return 64 byte if it's allocated in compilation time. But if you allocated a dynamic time, this will only act as a pointer, so it will return you 4 bytes, 32-bit pointer. All right, so that's the problem. So if the size of is not going to do anything here, we have to take care of how many sizes, sorry, what is the length of the data that we are going to write to. So if you have 32-bit and you have buffer of 64, so first 4 bytes are used and you instruct this by 4, saying that the number of data that I am going to write will be 4 bytes, right? So these parameters are the same. So each process is the handle to process. So this must have VM write, so that means virtual memory write, and operation access to process. But we are not going to use this one. So in this case, we are going to use process access all memory writes. So that means all writes. So you have VM write, VM read, VM operation, everything. So this base is as discussed earlier, the point to the base address in specified process which data is written before the transfer occurs. So this says that further described. So this is buffer to the pointer, and it's the size of number of bytes to be written. So this is the return back variable, pointer to a variable that receives the number of data bytes transferred to the specific process. Okay, you can send this null, but we are going to use it in order to verify whether our data actually written. All right. So if the function succeed, it will return non-zero. That means 1 means true. Function is 0, that means false. You can get the get last error. Okay, as we discussed. All right. So this is in kernel 32, as I mentioned earlier too. So now this is in C++. All right. So you can use in C or C++. But how can we get this into our .NET code? All right. So this is in C++. We cannot use C++ code directly in .NET. So how are we going to do this? Before we do the importing, let's discuss the other function, ReadProcessMemory. All right. Right. Let's discuss how the ReadProcessMemory. The functions are same. Let's see. Functions are same, as the method is same. Instead, we are not sending a byte, we send a pointer to a byte array. Okay, here is our ReadProcessMemory. So let's go to the documentation. All right, this is ReadProcessMemory function. So as you can see, when you compare with this, all right, let's compare. So the both needs this one also needs h handle, so h process, handle process. So the base address is always needed. So what is the we are going to use? This is the buffer that we are going to receive to. All right. So earlier, this one is the writing buffer. Here is the buffer that we are going to receive the data, and how much data we are going to receive to our buffer, and how much number of bytes actually read from the process, the final parameter. All right, so these are the main two functions for our trainer program. All right, also there are some functions that helps us to get to this use this read process and write process memory functions. All right, so one such function is find window, and let's discuss find window function after we explore how to invoke our these main functions in C# platform. All right, so before we go for these two functions, let's get some simple functions. So let's go for show message box. All right, I believe there is such function like this, but let's see. I believe it's go for Windows. All right, this is message box function. All right, we're going. Let's get this one first. First, let's see how to use this function to get to a message box, our C#. All right, the C# already has the message box class, so message box.show. That's all, but that's in .NET. All right, but here we are going to use a Windows native version in order to check our invokes are correct. All right, so let's see how to import this function into .NET, and from there we execute this function, so we can import the other functions as we do in same. Right. All right, so here's the message box function. So this just display a model dialog that contains a system icon, set of button, blah 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 blah. So this is the message box function in C++. Now we are going to import this very function into our C# class, and let's see how we are going to display a message box in our C# application. So this just need HWND, that means handle window, the window handle. We can pass a null or 0 for that, and the text, caption, title bar. This type is the one that decides what are the buttons and icons that you are going to display in your message box. So you can see that these are the values for uint. So you have about, retry, ignore. If you pass these to L and 6L, that means long value. So cancel, retry, continue, help with the help button. Others, these are all in this description, so I'm not going to go through this one by one. All right, let's use this to test this. All right, so this is dialog result. All right, okay, now how are we going to import these functions? So these C++ operating system, these are platform provided function. All right, these are platform provided functions. So basically how we are going to import these platform provided functions to our C# application. All right, so still my C# is installing here. Basically there is a website called P-Invoke. All right, so in Google, let's say P-Invoke. P-Invoke stands for platform invoke. So basically it invokes platform services. So this website contains the definition in C# in order to invoke the platform services that we are going to discuss today. All right, so let's start by this one. all right, this message box function. So here we go, the p-invoke.net, the platform-invoke interop wiki. All right, so this site has most widely used functions to us to import in our C# projects. Okay, this is the website. So look, so you have add-in also, add-on. You can install this add-on if you need to. So we are interested in this function message box. So let's go for message box. So most of the head of DLL files are here, so you can browse through the DLL if you want. So we have ntdll also. So if you go for ntdll, so you have ntclose file, ntquery information, blah, everything, blah blah blah. So you have this and you can call it. Right, so enough of that, let's go for this message box. So I'm just going to right click, copy this, and here right click, paste. So as you can see, my C# is also finished. So it's finishing up phase now. So I'm search here. All right, so what is the deal? Now we have multiple entries here. WTS API, this is send message. I believe this is the one. So let's double check this. So go bottom, you will see what is the DLL that exports this. All right, so this is example code. So you have user32 DLL. So I need user32. I'm go for this one. Let's do this, right? Okay. So these are the manage API, Windows form. These are unmanaged managed API, so you can use the direct.NET API for that. All right. So we have C# signature. So this is the one that we are going to use. All right. So this says Dll Import. So in Java, the similar one is load library. As you're familiar with that, you have to load the library. So you can use load library in Java if you are going to use a platform invoke. So let me get this one complete. All right. Okay, so it says Dll import. So import the user32, set the last error to true. That means you can get the last error. So this automatically selects the character sets for us. After that, the extern int message box, hwnd string text caption uint type. That means unsigned integer. Okay, let's get back to coding. So let's get our hands dirty. All right, I'm going to add a console C# application. So no funny Windows forms here. So I'm just going for projects. So C#, Windows desktop, and console application. Okay, so here's the console app. So I'm going to use this one will be our trainer. Okay, so I'm just going to use a trainer. This is our solution name will be trainer. So this will be our trainer base. Okay, so under this one we will have ADLLs and stuff also. Okay, so here I'm going to add another project that is C#, same as about earlier C# projects. This time I'm going to add a class library. So this class library is responsible for all the memory related tasks, such as opening the process and opening everything. So we are going to isolate this from the interface. So this will be our memory core. So it will be rather process and memory core, right? Right now this DLL is going to be empty, so no code here. So class, and this is, let's name as core. This is call. Alright. Okay, so this will have all the write process memory, read process memory, and also this also have the locking window, opening process, every functions go, every memory related process, writing, reading related functions are implemented in this class. Alright, so I'm going to add the constructor here. So in this trainer program, the first most important thing is the window name. Alright, so we are going to lock the process by its window name. So I'm going to receive the window name for this. Okay, so this is the lines that I'm going to write in this file, right? So let's go back and see how to invoke a message box using our console application. So notice, so I don't have the message box. That is because, so I have to use system.windows.forms library, which is in console application. I don't have system.windows.forms library. Alright, so if I double check this, so I have system.windows. No, there's nothing called form interface. Alright, sorry, namespace here. So here in this, at this moment, I have no way of getting the message box, but if I can get the Dll Import using our p-invoke.net, I can get the message box done. So I'm just going to copy this one. Right here, I'm going to import the DLL. Okay, I have to import some, so I'm going to go control and press ctrl and dot to import the interrupt services. Alright, so here platform services can be moved because interrupt services are now included. So I'm just going for message box, so you can see I have that. So here I'm passing 0, text is yes, let's say hi there. So caption is testing P-Invokes. The type is, let's see, so I need OK box only. So here if I scroll down, scroll a little bit up, sorry, so here I need the information, so I'm just going to use information button. Okay, icon warning, icon information. Alright, so this is the one that it use. So I'm going to move this L here, so it is long. Alright, it's working. Alright, so testing P-Invokes. So I have hide there message displayed here. Yes, you can see. So this is simple. You can just import the function to our C#.net, and then you can just use it like you use a normal C# method. Alright, so this is simple. So you okay, and it's gone. So again run, so you have this one. Notice these are completely depend on Windows operating system. So if you are using mono, if you use this, then your application will fail because this is now platform dependent. You cannot run this one is in mono. Alright, so if you are going to do that, you have to do special checks whether operating system is Windows or Linux, and if you are running Linux, you have to use a different Dll Import and different method altogether in order to display a message, you have to find the message box in that platform if you are going to do that. So we are going to do these things. We are not today we are not going to write process memory or read from process memory, but today we are going to cover the ground in order to start the write process memory and read processes memory. All right, so we are going to first we are going to find the window. All right, so we are first going to cover the find window function. So as I stated earlier, this DLL, so this class is responsible for everything. All right, so here I'm going to import the DLL imports regarding the find window. Before that, let's see how the find window works. Okay, so I'm just going to find the window. Okay, find window function is, so you have p-invoke function below also. So it's in user32 DLL. So basically it requires two variable. All right, so you are returned with handle to the window. So you have the find window, the class name, and the window name. All right, most of the time the class name is going to be empty string, null, or 0. All right, so first thing we are going to do is we are going to find the window. All right, so let's import this function to our C# application using p-invoke. So I'm just going to copy this one. So notice this is in user32. So if multiple entries are displayed, we are going for user32 directly. All right, let's see. Okay, we have, so this is the one, user32 DLL. So this is the find windows. Okay, so there is an alternative method that they are suggesting, that they say that you can avoid using find window, which is native code, by calling combination of process.get process by name and process by main window handle. So basically they said there is a method in C# that automatically do this for you. All right, so but for now we are going to ignore that. We are going to use from the basic. So we are going to use the ground up. Okay, get process by name and main window handle. So then you can avoid this find by window. All right, so I want you to play around with that. So let's see whether you can do by these two. I will try this one later and tell you what's my outcome is. All right, so this is something new that I didn't also know right now. So basically now let's go for the find window function. All right, okay, so there's another alternative. Get window thread process. If you need to find windows given process ID. All right, now we are not interested in this one. So let's go for C# signature. Okay, all right, so lots of comments are there. So this is the one, DLL import. Now we have two DLL imports. So what is the difference between these two? So this is said find window by caption. Okay, so you can get the caption. So this caption is main, so you can find the window by caption, or find window, the window name. All right, let's go for find window. Right, so find, sometimes the games does not have caption box. So in this one has, sometimes the games does not have the caption, so you cannot find the caption. So I'm going for find window. All right, so okay, now paste there. So this is our first function. I'm going to import the runtime services. All right, the first function is define window. Okay, then in this trainer series, we are after the finding window, we are going to use a second method called the get window thread process ID. Okay, why we are going to get the thread process ID? That is because we need process ID in later functions. Okay, so after the window, after we search get the window, we need to get the process ID for that process. Therefore, we use get thread process ID. So let's import that one also, and after that let's code the find window function and get process thread ID function. Okay, so I'm going for all right, here we go. So get window thread process ID, right? So it's neither handle, and you get the process to this one, pointer to variable that receives the process identifier. That means process ID. If this null, get window if this parameter is not null, get window thread process copies the identifier of the process variable. Otherwise, it does not. So get window thread process ID. Let's go to p-invoke and find there. All right, what is the DLL is user32. I'm going to paste this. All right, user32. All right, this one. So this is under user32. So let's see whether there are any alternatives. No alternatives. So this is the one. So right, I'm going to use this out version. It is easier. You just declare an integer and get the value. So you can use the pointer if you want that using a pointer. So this intptr is, we are going to use this intptr lots in this one. So today we are not going to use WriteProcessMemory and ReadProcessMemory because we have to do some sort of work before we go there. So what we are going to do today is actually we are going to get these IDs and process related information first. Basically, we are going to complete this constructor here. All right. So once we do that, that will be the end of this video. Right now. So let's get the find window. Right. So first we need to find the window here. Now it return a unsigned integer. All right. So I'm going to use a var hwnd equals to find window. So I got class name for null, and the window name is the window name. All right. All right. So this is the handle. So basically it says that it returns a intptr. It says now if we go back to our documentation, it says the return value section. If the function fails, the return value is null. All right. So if now this is intptr, all right. So you can get the null check by using this. So if so the int32, you convert this to int32. All right, if this is null, then we are going to throw a new exception saying that we cannot find the window. All right. Right now, if this succeeds, the no exception is thrown, and we are going for next one. This says now after that we are going to get the thread process, the process ID for this window. All right. So let's go for this function. All right. So I need intptr for that. So I'm going for PID, sorry, intptr. All right. So you can use this check also. If this is 0, then you can. So let's see whether we can check this actually by this is our window name. So the window name is main here. I know the window name. So I'm going to add the reference to our project. So let me add the reference here. So go for projects. Press OK here. All right. So I added it. So I'm going for so this is my core. C equals new core. Just using core here. Control dot. So using process memory. So window name is main. Okay, so here I'm going to put a breakpoint here. So in order to we can debug the process. All right. So I'm just going to start this. If hit F10. So this is my initialization of the pointer. Right, now I have the HWND, so my window is not 0, so that means we have valid window, right? So what happened if we enter a incorrect one? All right, so this throws an exception. Okay, so our first function call was correct, so I'm just going to remove this. Now after that, now I need a process ID. Okay, so why we need process ID? The process ID is needed for the open process function. So when we are going for process related functions, we need to open the process also. Next one, after that we can go for write process and read process memory, which we are going to implement the reading and writing in next week. So here let's get the process ID. All right, so let's see what is the return value if the get window thread process ID success. So return type is DW. All right, this says the return value is the thread of the given process. So it seems that the return value, I'm not going to use the return value. Okay, so here get window thread process ID. So I have the handle now, so I'm simply passing the HWND intptr Here also I am going to use a PID. Alright. So let's see whether we can get this value. So I have main process open. So I got this one. So looks like I have 0. Let's see why we get the 0. So I think I passed the value. Basically I don't need to set this 0. Let's see, they say that in C++ that p-invoke, so unassigned local variable PID, looks like we have to use the other write process thread window ID option. Alright, so I thought that we could use a intptr version, but I believe we must use this now. Alright, so I'm just going to use a difference method now. Now I'm going to use uint, that is PID. So I simply use out keyword here. So now everything's gonna be okay. So I have PID of 1160. Let's see whether this PID is same as the one we received. Okay. So can we get the process ID? Okay, select columns. So process identifier here 1160. So we also got the 1160, so the process is correct. Now we are going to open the process in order to get the handles for reading and writing. Alright, so that is open process. So open process is also exported in the platform. So you got desired access, so inherited handle, and the process ID. Alright, so it says that what are the access you need. So if the handle is true, the process created by this process will create it, otherwise. So I am just going to set false for this one, and I pass the PID. Okay, let's get the return value back. So if the function succeed, it is an open handles to specified process. So most of probably it will be a intptr, not sure. Let's see. If the function fail, it returns a null. Okay, so open process, copy and paste. Okay, I believe it's in kernel 32. Yeah, it's kernel 32. So kernel 32, open process. As I guessed, this one is a intptr. So we are going to open the process right now. So this is our third Dll imports. So I believe we need to import this one also. Now everything's okay. Alright, now here. Okay, now we can use a var. Remember, we have to get the return values correctly, otherwise we may get into trouble. So open process, return value is function fail, the return value is null. So again we have to check for intptr 0. All right, so var p handle is equals to open process, and I'm going for access flag. All I need, all process, all access. So basically read, write, everything I need. So after that, we are not going to inherit the handle, and the process ID is PID. Sorry, if we cannot open the process, why this is all right? Looks like it says for int asks. I'm going to just convert this one. So if p handle is equals to, so this is 0, then we are going to throw a new exception saying we cannot open the process with ID string interpolation. Right now, so if the exception is not thrown, then this is going to be fine. All right, now I'm just going to use one last function, that is close handle. We must need that when we exit the application. We should use the close handle, so we should close the process handle. So we should, so this is just saying that handle two objects. So if it's true, then, so if it's success, I believe none, 0 return value. Okay, so it's in kernel 32. So close handle, get the close handle here. So this is in kernel 32. So this is signature that we want. I have to import these things. For now, I'm going to, at the end of this code, I'm going to close this handle. So I require intptr, so p handle is the correct one. So let's see our success in this far. All right, I get the PID, and also I have the p handle. Right, I'm going to close the p handle. It's now closed. So if I go back and try to close this, I get the exception. All right, so everything works as expected. Right, now as you recall, you have to get the address, base address and stuff. All right, so if I open our program here, so you can see the 23, the value in progress bar. So this one, you see that this base address needs to be taken. All right, otherwise your write process memory and read process memory functions going to be failed. All right, so we have to get this module's base address basically. So we have to get this one's base address. So how are we going to do that? Let's do that right now. So we are not going to use any Windows platform related function for that. Okay, basically we are going to use a .NET function to do that. So let's do that now. So I'm going for the process information. So I basically want to get the information about this process. Okay, so process name and exe file name, everything like that. All right, so I'm going to declare a process variable. So I'm going for var process equals process namespace. So I have to import this system diagnostic process. So here get process by ID. So I have the process get process by ID. So here I'm going to pass the PID here. Now I have everything. Okay, so let's try to debug. And why this? Okay, again I have to cast this to the integer. All right, now let's do a debug run. So I have the process. Okay, see, I have everything. So I don't have exit code yet. I have the process ID here also, and I have the main window handle here, main window title, everything is in. So I have page memory size and everything. So I have to get the base modules address. So this process, as you can see, this process have multiple modules. Okay, so you have see the module, there is a collection. Why there is a collection? So I have 61 modules. All right, so 61 modules. What are those? So I have NTDLL, MS Core DLL, as you saw in our last video in our OllyDBG, where we hacked, or rather patched, the executable file using assembly code. You saw there are number of modules that was C++.NET. So this one also C++.NET. So here also we have this much of modules loaded here. So as you can see, you have CLR, MS Core EE, kernel 32, everything is loaded here. So if you click one of these modules, you will see the address and stuff. So the base address is this one. Okay, so it also has the file name, right? So our module, so how do we find module, correct module? The best way to do this is to use the very first module in your module list. Okay, let's get that module's base address. So since this base address is going to used globally, I'm going to declare a global variable. It's a static variable. So static. So this is private static. Oops, this is in constructor. Okay, so process. So my first module. So here module's base address is this one. All right. Also, this process handle is also going to be global. All right, so I'm going to remove this var here. So this call will be moved to a different call, different method rather. So I'm just going to void release. So oops. All right. So to the completion, so I'm going for c dot like I forgot to add the public. So this will do it. So now we have the module base address and the process handle. So we can use the write process memory functions and read process memory functions, and also we have the base addresses also. So so that's the end of this video. So today's video we discuss how to import the platform services into our C#.NET program project, and we opened the process, we found the window, we opened the process and got the thread ID and retrieve the thread process ID, and after that we retrieve the modules and first module's base address, because the first module is the most of the time. It's true that every time, most 99.9% the modules first module is your executable program. I will search whether there is a better way to get the actual module, but for now this will do our job. So in next video we are going to write to this process, we are going to alter these values using our C# program by using WriteProcessMemory and ReadProcessMemory functions. So in next video we will write and read. Until then, have a nice week and stay home, and I wish you everyone a good health, and so stay safe and stay home. And while you are staying home and safe, don't forget to subscribe to my channel. It is Fun Text with Hashan, and click the bell icon so you will get the notification when I uploaded a new video. And with that being said, I wish you a wonderful week, and goodbye, and thank you very much.